Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you see the links for the O-level and the A-level group.
Welcome back, friends. This is Dr. Mlelwa Lecturers, the facilitator in this session. I am Dr. Mlelwa, undergraduate student at Mumbiri University of Health and Allied Science. So we are continuing with our status of matter topic, and in the previous session we discussed about the concept of degree of association, how to derive the formula of degree of association, and all the aspects about the Van 't Hoff's factor and different formulas to calculate the Van 't Hoff's factor. In this session, I want to discuss with you some few examples about the degree of association and dissociation. So as you can see how the questions they are asking. So I don't have my calculator here, but I will be just explaining the concept of how to taking data from the question and how to solve the questions. So I will not be computing the data in the calculator, but I will be explaining to you, and I'm sure that if you are the advanced level student, you will be having your own calculator and you will calculate yourself. If you will get answers different to my answers, then you can comment in the video below, and then I can walk through your comment, and then you can see what was wrong in my calculations. So in our first example, 20.86 grams of phosphorus 5 chloride, that means phosphorus pentachloride, are allowed to vaporize on 5 dm cube at 175 degrees centigrade. A pressure of 1.04 times 10 power 5 pascals develops. Calculate the degree of dissociation of phosphorus here into phosphorus pale and chlorine. So now solution, and we are starting with the data given. We are given mass is equal to 20.86 gram. Then we are given temperature is equal to 175 degrees centigrade. We are plussing 273 to get the Kelvin temperature. Then we are given pressure is equal to 1.04 times 10 power 5 pascals. And from there we are given volume is equal to 5 dm cube. And then the question is calculate the degree of dissociation of phosphorus from yule pale to yule pale. So equation will be phosphorus pentachloride dissociates to form phosphorus trichloride plus chlorine gas. So as we know, our formula that the degree of dissociation is equal to Van 't Hoff's factor minus 1, then it's n minus 1. And n is the number of particles formed after dissociation. So for example here, if we balance our equation, we can see that only 2 particles have been formed after dissociation. So n will be equal to 2. That means here is 1 and here is 1. Adding them, the sum is 2. So the number of particles after dissociation is 2. Now we have one task, that is to calculate the Van 't Hoff's factor. And as we know that the Van 't Hoff's factor can be calculated in various ways, as we said before. But in this question, will be calculated as the expected monomers of a gas divided by observed monomers of a gas. Observed monomers of a gas. So I have used this way because we have various ways, but according to our data which have been given, kwamba tungeangalia concept ya kutumia observed volume ya gas pamoja na expected volume, ni kwamba hapa tuliopewa ni volume expected. Now kwa sababu hatuna observed monomers, tusingeweza kutafuta observed volume. Now expected monomers of a gas, expected monomers of a gas, manake ni monomers of phosphorus pentachloride. So hiyo inaweza ikawa calculated. our task is to calculate the observed, kwa sababu expected is the one which is calculated from the normal formula of the gas. Now our task is to calculate the observed. From the ideal gas equation, PV is equal to nRT, and as we know, number of moles is equal to mass divided by molar mass. So PV will be equal to mass RT divided by molar mass. Molar mass will be equal to mass RT divided by PV. So hapo tunaenda calculate molar mass, and this molar mass is what we call as observed molar mass. Na data zote tumepewa from molar mass is equal to mass RT divided by PV. Data zote tumepewa. One major thing which we should consider ni unit za data. Kwa mfano tumepewa volume yetu tumepewa kwenye dm cube. Hii Pascal ni sawa sana kusema Newton per meter square. Now if we want to use the pressure in pascals, we must convert the volume into meter cubic. That means we will get 5 times 10 power negative 3 meter cubic. So lazima tu convert volume yetu kwenda kwenye meter cubic. The universal molar gas constant tutakayotumia R itakuwa ni ngapi? 8.314, kwa sababu tumetumia pressure kwenye meter cubic. Lakini temperature tutaiconvert kwenda kwenye Kelvin, tutapata 448. So what has been remained here is to compute the data in the formula and then to get the final answer for the question. Kwa hiyo ukiingiza hizo data kwenye formula, naona kuna one mistake. Hapa ilikuwa ni 20.86, hapa it is 20.85 instead of 6. So manake hata jibu utakalolipata ni kutokana kwamba alicompute ngapi? 5 instead of 6. So ili jibu alilolipata kama ni nani? Observed molar mass, it is because umecompute ngapi? 5, it is not 6. So ukipata observed molar mass ambayo sio hii, hiyo ni error kwenye nini? Kwenye kucompute. Now the expected molar mass tunaikalculate kutoka kwenye formula phosphorus pentachloride, napata 208.4. Na actually is 208.4 na observed molar mass ni 149.34. So Van't-Hoff's factor value yake ukiapproximate kwenye 1 decimal place utapata 1.4. In physical chemistry we like presenting the answers in 3 decimal place, lakini kwenye baadhi ya calculation kama hizo unavyokalculate Van't-Hoff's factor, normally we are rounding it to 1 decimal place it was calculate kwa urahisi. So rounding up the Van't-Hoff's factor to 1 decimal place utapata 1.4. Now the degree of dissociation alpha, as we said, alpha will be equal to Van't-Hoff's factor 1.4 minus 1 divided by n minus 1. So as I said, n is equal to 2, so degree of dissociation itakuwa sana 0.4 divided by 1, that is 0.4. So degree of dissociation is equal to 0.4. That's the answer. Or if you represent it in a percentage, you can multiply it by 100 and then you get 40 percentage at the degree of dissociation. It can be represented as percentage or as decimal. So that's the end of the first question. And don't worry if you got the molar mass here different from this answer, because I think the major error was to write 8.5 but not 8.6. But I hope the degree of dissociation still cannot vary in large extent. Now let's move to our second example. In the second example, we are calculating the degree of association or degree of dimerization of aluminium trichloride. That is simply, it is aluminium chloride because this is the ionic compound, so we can't call it aluminium trichloride in naming. So if the molecular mass of aluminium chloride at 192 degrees centigrade imekuwa calculated kuwa ngapi? 185 gram per mole. 185 gram per mole. Here in this question it is very simple because we are already given the observed molar mass. molecular mass ya hiyo hapo imekuwa. So this is observed. Ile ambayo wameiona ni observed. So we are saying that observed molar mass will be equal to 185 gram per mole. Now let's calculate expected molar mass. Itakuwa sana ngapi? Molar mass ya aluminium chloride. So aluminium ni 27 plus chlorine 35.5 mara 3. 27 plus 35.5 mara 3 utapata expected molar mass 133.5 gram per mole. So it is very easy. You are going to calculate Vantius factor. Ni nini? Expected divided by observed. Kwa sababu hii ni molar mass. So Vantius factor ni expected molar mass. Expected molar mass divided by observed molar mass. So Vantius factor ile pale atakuwa sana ngapi? Expected hapo ni 185. Expected ni 133.5. Observed ni 185. So Vantius factor. Na hapa lazima tupate jibu ambalo ni less than 1 kwenye association. Vantius factor tutapata ni 0.72. So as we said kwenye association, degree of association is equal to Vantius factor minus 1, then divided by 1 divided by n, then minus 1. So kilichopo hapa ni kwamba huyu n hapa ndo number of particles ambazo zimekuwa associated na kwa hapa ni 2. So degree of association itakuwa ni ngapi? Ni 0.72 minus 1 divided by 0.5 kwa sababu it is 1 divided by 1 divided by 2, that is 0.5 minus 1. So degree of association itakuwa ngapi? Hapa itakuwa ni negative 3. Negative, okay, ni 1.00 minus 0.72. Hapa tutapata ni 8. Hapa ni actually it is 2, so it is negative 0.28. Negative 0.28 divided by negative 0.5. The final answer about tutapata ni 0.56. 0.56. Don't worry kama utapata jibu ambalo sio exactly kama hili. Sio exactly kama hili. Sababu ni kama 28 gawa kwa 5, 28 gawa kwa 5. Actually ni kama unaweza usipate jibu hili. I think kulikuwa kuna mistake katika kucompute data. Might be ziliingizwa tofauti. Lakini this is the degree of association, not dissociation. Association. So yeah, it's like that way. Now that marks the end of our discussion on the abnormal molecular mass of gases and the calculations of degree of association and dissociation. Don't forget to join my Telegram group ili tuweze kuendelea discussions mbalimbali za maswali, kwa sababu siwezi nikasolve maswali yote kwenye hii vipindi. Kwa hiyo tunasolve maswali machache for examples, and then other questions unaweza kucalculate mwenyewe. If you are unable to join my Telegram group, is my best the best option ambayo you can meet with the different students, lakini pia you can meet with me, then you can solve different questions regarding the degree of dissociation and association, or even regarding the other parts of gases. In the next lecture we'll start the discussion on liquids. So this session also marks the end of our discussion on gases. Kwa tumeshamaliza kila kitu kuhusu gases. Session inayofuata tunaanza kudiscuss kuhusu liquids, introduction to solutions, that is the liquid state. We have already moved from gaseous state. In the next session we'll be discussing about the liquid state. However, we'll be touching some of the few concepts of the gases, about the Dalton's law, about the partial pressure, the mole fraction, the degree of dissociation. We'll study them again later. The ideal gas equation tutatumia tena baadaye huko mbele kwenye solutions, kwa sababu In some of the aspect to discuss solution, lakini kivipi solution inaweza kabadilika kuwa gas na baadaye ikawa tena solution, about the concept of vaporization and things like that. Stay with me, stay tuned. Session is the uploaded. Just subscribe the channel and join my Telegram group for more discussions. Thank you everybody. Let I wish you nice studies.